All right, so without further delay, let me introduce our first keynote of the day. Andy Terrel is the president of NumFOCUS and has been involved in the wider scientific Python community since 2006 and a contributor to a number of these open source projects right here. Andy received his computer science PhD at the University of Chicago in 2010. He has held research positions at the Argonne National Lab, Sandia National Lab, Institute of Computational Engineering and Sciences at the University of Texas, Austin, and the Texas Advanced Computing Center. In the industry, Andy has served as the lead developer at Cove during its early stages where he helped bring a record-breaking SanDisk array to market. Andy has also worked with Enthought and was part of the founding team at Continuum Analytics, which is now Anaconda. So with that, please help me welcome Andy to the stage.
Awesome. Thanks everyone for sticking around to the last day and showing up early. I hope the coffee and bagels wakes everyone up because I have some, start off with some deep questions. And the first one is just, why are you here? So it's a question worth repeating. Why did you take 3 days out of your regularly scheduled program to come here? What made you come learn about our community that's been 2 decades in the making? Right? So a lot of people come to PyData and say, oh, it's a wonderful community. It's a community built on many years of toil and sweat of our scientific brethren. I wanted to tell you a little bit about that. But before we get there, what brought you here today? Was it a Coursera lecture that you learned about the tools and the interesting things we do? Was it perhaps some particular tutorial that you saw? Maybe you could reach out and thank that person for doing the work to show you how that code worked. Was it something that you did at work? Did you innovate, create, or modify some piece of code that actually helped someone solve a problem? Or did you just have, want to get off work for 3 days and do a low-stress environment? It's cool, too. I see you. So why NumFOCUS is here, we put it boldly in our mission. We're here to promote sustainable high-level programming languages because we believe that high-level programming languages have an outsized effect on what you're able to accomplish. So we put that in our statement. We want to sustain high-level programming languages, open code development. We believe in open development versus closed development because without open development, it's very hard to share those results and bring a diverse set of peoples together to learn and progress society. And finally, we're here to promote reproducible scientific research. Reproducible because it's not science without reproducibility. You can quote me on that. And science because we believe that scientific tools have an outsized effect on the world at large. That's why NumFOCUS is here. But some say, ask the question 5 times. I'll spare you. I won't ask 5 times. So I'll bear to ask again. Why are you here? Do you like jobs with every Fortune 500 company in the world? Does that motivate you? Does every NASA mission for the last decade motivate you? Does delivering 1 billion page views a day in a consistent, reproducible manner motivate you? Does building models to understand and predict our amazing world empower you? At NumFOCUS, we accomplish our mission through 4 major channels. First off, education programs. Everyone asks me, likes to talk about NumFOCUS and how we do projects and everything else. Fundamentally, at the very beginning, we had decided NumFOCUS was an educational platform. It just so happens our education is around open code. Second is fiscal sponsorship. All these projects here exist because people give their time, energy, talent, and treasure. And we want to give back to them, so we provided them a way to take money for that time, talent, treasure, and continue to do their programming and their projects to help us build those cool new foundations. We run events like this one, meetups. We have over, I think, 200 organizers all across the world coming together to promote and learn about these tools to help leaders in the community make progress for our society. And finally, but not least, we come together for common challenges to help communicate with each other how we're tackling the world's problems. And we do that with our data science communities, but there's many like us, and we want to participate and bring people together to have a fruitful conversation. Which leads me to ask again, why are you here? Do you believe that scientific discovery can unlock the cure for cancer? Marius at Flatiron Health, who built Condiforge, does. Do you want to stop humanitarian crises? Stop the enslavement of marginalized people across the globe? Eric Scholes at Microsoft Research, who uses our tools to find victims of human trafficking, does. Do you want to warn victims of natural disasters across the globe? Kyle Manley, one of our core SciPy developers, does. For the most part, the people who come together and build these countless innovations are here to build a better world. And while we get excited about the code, and about the spelling of the libraries, and whether it starts with R or Julia or Python, I just want to kind of bring us back to why we're here to build open scientific codes. So I've asked you 3 times. Nobody answered, but I asked. But I seriously want to know. Everyone with a computer in front of them, please tweet, send an email. Let somebody know, why are you here? Could just be that James asked, or Dave asked, or Jim made a nice website, or Gina brought in had a flyer that you liked, or somebody in the committee came in. It could be that you want to learn a new tool. Anything is fine. We have thousands of people at all our events, and every single one is a unique reason. And unless we collect these reasons and share them with the world, people don't learn about our open culture and our open community. So I ask you now, please tell us why you're at PyData. And I would actually do it right now, but the AV system doesn't. Apparently I was having trouble earlier when I was trying to switch. So I'll assume that the internet is buzzing and the FOMO is going out. So that's why we're here. I hope you've established why you're here. And for the rest of my 7.5 hours, I'd like to talk about the 50 projects. But before we talk about the projects, I want to spend a few moments talking about innovation. So a lot of people like to talk about sustaining open source communities. And I think that's good, but really what drives those open source communities is innovation. And I want to talk about sustaining innovation. And I think that there's a lot of things in innovation to unpack, and then come back and say, how do we fit into that, and how can we progress forward as we consider the topics? So NumFOCUS has 3 rules. They're not an Isaac Asimov sort of like kill the world type 3 rules. They're just 3 rules for our projects. And we tried to come up with only 2, but we kept, darn it, a 3rd one keeps on coming on. So the 3 rules for being a part of our community, so at least for a project to be officially supported, is first, build for science. Many organizations, many open source cultures are kind of built for different reasons. And those are all great reasons, but we came together as scientists to build for science because we felt that there wasn't a good enough focus on the scientific coder from all the other existing organizations. And because of that, we only bring on projects that are really built for science. I get people ask me all the time, why don't you bring on, like something like Read the Docs? Read the Docs is an amazing project, but it's not built for science. And when they came to us, we've luckily helped them find another home to keep us focused on the scientific programmer. And science happens everywhere. We're not academics. We're not only in government labs and companies, backyards, the trenches. And it's also true that other people besides scientists use our codes. And we're grateful that they've taken our codes and helped us find the bugs, and sometimes graciously given us bug reports, sometimes angrily given us bug reports. We take those too. But, we want others to use it any way they can. The diversity and use, the repurposing of digital work, the recombination, is what drives the variety and innovation that has spurred our community for the last 20 years. The second rule is be kind to each other. People say this in a lot of different ways. People have codes of conduct, people have governance documents about how decisions are made. But at the end of the day, we want to work with people who want to work with us. It's not necessarily about rules of exactly how you have to say that, but the internet can be kind of an unkind place. And if that's where we're going to gather, we want to learn from each other. We want to be kind to each other. And third, is lead openly. There's a lot of different ways to write open source these days. The way we choose is a radical openness. More than a license, more than just comments in public, but taking code from others, allowing others to recombine your code, helping people use the best practices, and in open, meaningful reviews. Those are our 3 rules for our innovation of our community. And the community is here. It's open, it's diverse. It's in LA, it's in London, it's in Paris, it's in New York, it's in India. We just had PyData days in New Delhi, in South America. It is a global community that you are a part of when you're part of a NumFOCUS events. And the 3 rules are not new. They're maybe not even surprising, but they are controversial. And if you don't believe me, just ask yourself, would Genghis Khan have ever shown his plans for ransacking a city? Maybe that's a little heavy-handed. Take an x86 chip. Could that have been developed in an openly collaborative fashion? If you read The Soul of a New Machine, one of the best books of developing companies of technology, you might come to the conclusion that no, you can't develop openly. But we disagree, and we have the proof in the projects and the innovations that you all have brought to bear to show for this culture. And I have actually been asked to talk about innovation a few times, and I always like to use the analogy of the first flight. We see here the Wright brothers and their first flyer. And immediately our eyes are drawn to this wonderful contraption that was an amazing feat of two individuals. And I want to say, turn your eye away from that contraption and look more at the culture of innovation that allowed their focus, the variety, the failures, and the systematic repeatability that led to that invention. So what created the innovative culture that led to the invention? And I encourage you, if you ever have a chance, to go to the Outer Banks of North Carolina and visit Kitty Hawk. And this was the innovative environment at Kitty Hawk. A hill and a shack. Wasn't a pristine enterprise. Wasn't vaulted academic lineage. His two brothers who lived in a shack, who ate, slept, everything there during those months that they were experimenting. They lived in the shack at the end of the hill so that when their contraption failed, they could pick it up and try again with the small modifications. By moving to a place where failure was easy and not criticized or demeaning, and being able to focus on that innovation day in, day out, they were able to do 3 flights a day. As opposed at the current age, people were taking weeks to months between each flight. The same story was repeated with the Gossamer flight, the first human-powered flight, where they built not just the contraption, because the contraption eventually got built, but they built a system for testing and repeating and failing and learning. And I believe that that is what our open culture has provided us. An innovative culture to learn together. And I believe that the story of the Wright brothers is often told over and over again in every business book. Go read Pixar's book, or How Google Works, or the magic of Amazon. All of them talk about building this innovation environment. But I don't know about you. I'm not happy that so many of these innovations only happen to a very small portion of the population. So while the Wright brothers had the affordances that let them go spend months on a beach where there's good weather for flying, not everybody gets to do that. And I believe innovation comes from everywhere. Whether you're in the Middle East, in the African villages, or just the bad parts of the subway, which I've been to all these places and the bad parts of the subway smell much worse. So if we want to believe in building an innovation platform and a diverse platform, we need to build it in a way that's open to the world. And that's what NumFOCUS means when we say open code equals better science. So to build that sustainability, that sustaining environment, what came out of it? Many people are probably here because of these projects. But where do these projects come from? Why are they here? What is the principles by which they were developed? Sorry. Hit by the animations. Oh my. So I like to talk about the different activities we do, and I usually gauge it in my life as a researcher at an academic computing center. So first you start with a domain model. If you don't have a reason for computing, please stop wasting our electricity. We need it for other things, right? So we almost always start with a domain model. It means finding someone with domain experience. I had the wonderful experience of seeing Hurricane Sandy outside my friend's front porch and working with many oceanographers on learning why hurricanes bring such a huge tide wave and how to predict who's going to be submerged underwater. Then we have to get the data. The data wrangling is probably where we spend all our time, right? The joke, right? 90% getting data, 10% analyzing the data, 10% modeling. It's data science. I always like to show this off. This was a NOAA that's buoys with maybe the first Internet of Things in the world. You have 6,000 of these things along the coast of America that give these nice little matplotlib plots. Seriously, you go to this website. I know it's too small to see, but it's a matplotlib plot that's just a time series of up and down on a buoy. You put 6,000 of those together, and you have a pretty good data system for showing where water is going to be after a hurricane. Worked so well, they've started putting them in Indonesia and Japan and many other places in the world to understand tidal waves and how they work. Built in the 80s and 90s before Internet of Things was a real thing, but because of technology, we're now able to expand it and scale it throughout the world. The other aspect I always kind of go to is the modeling. Everyone likes to think of data science as modeling with no model. That's not true. I'll show you our modeling world here in a bit. Anybody know what these equations are? I always like to ask that. See, NASA's nearby. Somebody works on these equations, I'm sure. So the Euler equations, old and tried and true, and they work wonderfully for, putting water in a box and seeing how a wave works. Of course, we don't have water in a box, we have it on an ocean, and there's a lot of other things going on. So the model is just a model, just like any of our models. The fourth aspect of our work usually comes to computation. We have big machines, sometimes small machines, but we have a machine somewhere that has to compute this repeatable scientific discovery. And we wrestle with that. There's probably another aspect that people don't like to talk about, but getting your 20 computers to talk to each other is somewhat of a challenge sometimes. But we all like to talk about modeling and data experience. But the job's not done. Anybody who's tried to actually change somebody's mind knows that you can't just stop at computing the answer. You have to visualize the results. Here's a wonderful plot, won the John Hunter Excellence in Plotting Contest in, I think, 2013, from a friend of mine, an oceanographer named Kristen Thing, showing the tidal, the drift in tides and causing a very particular, very small part of the world. I don't even remember where it was. But the chart was able to elucidate what actually was going on in this oceanography issue to show the world how to predict a little bit better in that very small part of the world. You have to share the story. So the Jupyter and IPython notebooks have won major awards now because they've produced a new way of sharing your story, a computational way of sharing your story, a way that anybody can come in and recombine and change that story, put it on major websites like GitHub and render it for anybody to see. A small idea that was just a modification of an older idea. Notebooks have been around the 80s. The Atlantic had a great article about it. Why, for 40 years, did this idea just languish and be mostly tied to the halls of academia? Through open core development, code development, and innovative ecosystem, we're able to take that idea, let others recombine that idea, and spread it throughout the world to where now I've seen CEOs pop up Jupyter notebooks. I've seen economists, Nobel Prize winning economists as of a month ago or a few weeks ago, showing how Jupyter changed his whole computational stack. allowing him to share code and go find those economic theories to solve the world's hunger problem or poverty problems or whatever he goes after. And of course, my favorite, because I'm a geek, is the tools for building things. And that's the part that nobody ever wants to talk about, at least not at the business level. But if we don't have them, if we don't build them, the tools for building our tools, we can't accomplish the innovations we need. Just like the Wright brothers built their shed with their tools so they could modify their contraption every day, we've built our tools to modify our code and recombine our codes every day. So I'd like to just introduce you to some of these tools. There's 50 packages in all. I don't think I've seen a single person that has all of them put together in a single program. But for the most part, somebody has part of some of these everywhere in their codes. So we have Cantera, which I'm just using their sticker logos. So Cantera doing combustion, Scikit Bio doing bioinformatics, helping us find new drugs. MD analysis and molecular dynamics showing us the worlds of protein folding. Q-tip, which is this funky quantum graph guy here, doing quantum computing. SunPy, showing us the inner workings of the sun and helping predict how solar activity affects the Earth. AstroPy, helping redefine how astrophysicists compute into a world which allows that recombination. EconArc, which is a tool set for economists to build economic models in a way that is reproducible. How many people remember the Excel bug that caused the world so many millions of dollars? It's a group that says, let's come back to that open scientific leadership and show the world how to actually compute in a repeatable way, even in economics. Data wrangling. Everybody probably knows NumPy and Pandas. They're the cornerstone of so much innovation of our time. But there's this new thing, Xarray. How many people have heard of Xarray yet? A few of you. If you're computing large arrays on the cloud, go check them out. Because they've found very quickly that the innovation and accessibility and scalability of the cloud is great, but it does terrible things to our file systems, and we can't access that data nearly as quickly as we used to. So we have to create new tools. PyTables lets us use older technologies very efficiently, a big table and lots of memory and lots of disk space. Dyn, a dynamic array library, data retriever, a way to manage your data and tag it and understand how it flows. ROpenSci, which is a whole community of open packages for pulling down data and manipulating and modifying data in the R programming language. They saw we're having so much fun here in the Python world, the R world has joined us in ROpenSci and many other fronts. Modeling. This is the part we all, well, maybe not all of us, but many of us like to talk about, right? I can tell how many talks I go to, people want to talk about the one little detail in their modeling pipeline, which is awesome, but it's always part of the bigger picture. Up at the top, we have GenSim, natural language processing for humans. Most robots do my natural language processing, but sometimes humans do too. It was a joke, you're supposed to laugh, sorry. Scikit-learn, it's an affiliated project. It's defined the standard for how to build interfaces and machine learning algorithms. It's always the tool I pull off the shelf first, rarely the tool I end up using last. But that's innovation, though. Allowing an interface to dictate how everybody talks to each other is an innovation that's hard to capture hard to price, hard to put on the economic value on, but without it, you can't capture the value of the open innovation that's there. Jump is a new one from the Julia family of codes. Julia is an excellent language. Everyone should check it out. Jump is a multi-optimization library using many, I guess, algorithms for interior point methods and many, it goes beyond the typical convex optimization routines that you see in many libraries, and only possible because of the very flexible nature of Julia. A whole family of Bayesian analysis, PyMC cubes, Stand, Pomegranate. You're going to hear from the master later today about Bayesian analysis, and we have 3 libraries implementing his ideas. Shogun for very fast implementations of the standard machine learning programs. Stats models, because R has a lot of models that SciPy didn't have, and we wanted to be able to capture that. I think Skipper is going to be here today talking about statistics. Scikit image, because sometimes our data is in images and we want to pull them out. Again, EconArc for more economic modeling. We have SciPy, which, how many people actually import SciPy and use it? Some of you. But it's the underpinning tool of many of these programs. Without it, without the combination of it and I think on the beginning it was like maybe 10, 15 codes that it brought an interface to that were all developed in the 70s and 80s. It brings computing from the dinosaur ages, and at least in the computing world. Everybody always asks me, like, why is it so hard to install everything? I was like, well, you know, some of SciPy was written in 1966 by a group of folks who were doing linear algebra. I mean, they were good, fine folks, but they couldn't predict how our computers were going to work or how our compilers were going to work. So we now have SciPy that kind of makes that easier, but if you want to go into it, it takes a lot. You learn a lot of history. Phoenix, which comes from the computational mechanics world, people solving PDEs, partial differential equations, for everything from flows of oceans to, although they don't do much ocean modeling, but biological flows to heat flows to elasticity. There was even a movie made where they had some rigid plastic thing that Phoenix was able to help with. So a very rich ecosystem of modeling. Computation, because it's hard to compute all these things at once. Julia is a great language, just hit 1.0. I think there was a tutorial early on it. Dask, trying to be rivals to the Spark world and give native parallel computing to Python. It's easy, just like 6 lines of code, and you're running on hundreds of servers, or so they tell me. SymPy, bringing symbolic math to our everyone's lives. IPython, an interactive Python interpreter. I think once a friend of mine said, if you're not using IPython, you're doing it wrong. It's now evolved into Jupyter, as we all know and love, but IPython's still there, and it's still like a great tool. I was kind of crushed when James didn't show IPython console in his how to fix your code, because it's got a lot of amazing features for debugging those terrible 50,000 line programs that nobody knows how to deal with. Numba, putting code into LLVM and running it even on the GPU, making it super fast. Cython, a code that within 3 lines you're able to speed up your code very quickly to bring it down to the C level for Python. Theano, which originally was more of just that symbolic engine put together to produce graphs, has become the cornerstone of deep learning that is like taken off over the world, and it's been recently replaced by more competitive things on the market, but they're still there, still going through their end of life. Because innovation, things rise and things fall, and Theano is a nice story of a community that built a thing that now there are many types of Theanos that exist. Visualizing the results. Everyone knows matplotlib. Funny story, I happen to be responsible for DNS and web servers for almost all these projects. And one point, matplotlib went down, got a phone call from Google. I didn't even know Google called people. Apparently they do. And so now if you search for a matplotlib parameter, you'll get a nice little pop-up because our web infrastructure wasn't scalable enough for them that it'll tell you the arguments, or at least it did for me a few times. I haven't seen it lately. So one of the most popular websites on the planet, apparently, so popular Google will call you if it goes down. Bokeh, the savior of all of our time by writing hundreds of lines of JavaScript, hundreds of thousands of lines of JavaScript so we don't have to. If you ever want to get a dynamic plot in a web browser, go check Bokeh out. There's a great talk yesterday about it. Dash bringing Shiny to the Python world. Plotly's done a really great job of sharing graphs online, and now they've brought a new kind of system that allows you to put it all together in one web application. Orange, a tool for managing all the models and visualizations, mostly around text mining, but can use it for many other things. Very big in Europe, I hear. And YT, possibly the worst logo of all our stickers. I love this tool. They visualize galaxies. If you ever go to one of their presentations, just look up YT, like tutorials, and they have visualizations of billions of stars, and yet that's their 2D image. But there's got some really cool tricks in there. They just won a grant recently. They're able to index very large objects very quickly and do modeling in three-dimensional space in ways that are innovative and new. Many of our tools are leading the edge. YT is no exception. Ignore the sticker logo. Jupyter. Who here doesn't know about Jupyter? Awesome. Jupyter is a tool that has changed the way we do science. It's changed the way people communicate. And it continues to evolve. And that another project, Interact, that has come out to reduce the barriers to running a Jupyter notebook so that anybody who can click on a program in their computer can open it up without having to necessarily run a web server. It's also brought in the best designers to come up with nicer logos. Never mind they don't have a word mark, but that's okay. Go check out Interact. They've been doing very cool things and have a lot of visualization within the tool itself. And open journals, because you can't publish always your code easily. You can't publish your results easily. People don't always understand this controversial idea of open code development and innovation through the different aspects of the data science story. They only want a few of the stories. And so our community started a whole set of journals. The Journal of Open Source Software and Journal of Open Source Education, Joss and Jose. All reviews done openly on GitHub. And there's not really a rejection, there's just continued review to help you improve. So flipping the entire scholarly academic world on its head, changing it from a rejection-based promotion, self-promotion type of culture to one of leadership and open kindness and giving back to each other. And my final category, and I'll stop boring you with the explanation of every one of these projects, is the tools to build our tools. Straight in the middle, Conda, that wonderful tool that some will say fixed pip, others will say pointed weaknesses to pip to make pip better, but has become a tool that is used throughout our ecosystem. In fact, if you want to install the fastest TensorFlow, install Conda, because it'll install MKL, which is the fastest linear algebra library. That you're not going to be able to install yourself. I guarantee you, I've tried it. I have a PhD. It's hard. The folks at Conda shared that knowledge and keep it up to date. Conda forged an open source set of recipes, because one problem with having an open environment of digital recombination and recreation is we have a lot of packages. I show the 50 here, but there's probably hundreds more that under the hood, and we have an open community that can share those recipes for building. Spider, the IDE that's been around the block and lots of people still love and use, despite all the open new hotness coming out in the world. Spider has been there throughout the ages, bringing us an IDE that was built for scientists. And over here we have SPAC. How many people use supercomputers? Very few. If you ever use a supercomputer, you realize installing software on a supercomputer is a lot harder than your laptop. SPAC solves that for you. They do a good job. Check them out, the 3 of you that I saw hands. And Python XY, because installing on Windows used to be a nightmare. The Windows folks have kind of changed their viewpoint of our community and are now a very open member to our community, but Python XY is a tool that we once everyone used and now is perhaps used less, but still there to help people. So that's our ecosystem. That's the whirlwind tour that this open innovation has allowed us to create. So we have a few minutes left, and I'd like to tell you a little bit more speculative, like where we need to go. How do we build the next platform? How do we build what we're doing? The pitch I give to corporations is they have inherited a huge amount of risk because they're using our open platforms. If they don't give back, if they don't help us build a community. Here's some graphics. If you go to our website and download our corpus perspective, you'll see a lot more details. We take Matplotlib, Pandas, and NumPy that represents hundreds, thousands of lines of code, and on the work of 500 different packages. You have maybe Pandas, for example, has 10 core developers, only one of which is paid, 20% time, one at 10% time, and the rest unpaid. So NumFOCUS is here to try to help build a funding mechanisms of what we like to call a funding quilt for these people. And we do that through our events and our fundraising and our corporations. This is an old slide, PyData 2017. I didn't have the numbers this morning when I wrote the slide. I'll not lie, I wrote the slide last year and I didn't update it, sorry. But we have, 2016 we had 9 events. I think this year we're upwards of 19 or something. Hundreds of speakers, thousands of attendees, hundreds of people coming, diversity scholarships, reaching out to the community, and hundreds of thousands of dollars going back to these projects. The impact touches the entire world. We have meetups in 5 countries, that's supposed to be 3 continents, but sorry, didn't come out quite right. But 80 different groups, and this was in 2016. I'm not quite sure. We've just grown from there. I'm going to skip this slide. But the end of the day, what are we doing to grow the programs? I've come together after our summit and talked to people. We have 4 initiatives we're trying to kick off. Community road mapping, helping all of our projects build roadmaps so that they can bring investment into the community and the community can know where they're going so that there is a road going forward and we can understand how to move together. We're looking at building an academy program that helps people learn more about our codes, can get certified and provide solutions based upon our tools. But looking at cloud infrastructure services. The amazing tools that we use, once you get them set up once, you're amazed, it's wonderful, it's great, but man, is it hard to get all these things working on a cloud environment the first time. I can count on my hands 3 or 4 companies that do it and then go and try to sell that product for millions of dollars. I'd like that product to exist for the community in an open fashion. And then finally, auditing. People want to know when those tools are being used. They want to know how they're being used. They want to know, just like I want to know why you are here, I want to know why you're using our tools. So in conclusion, why'd you come here? Share that with folks. Join us in our innovation. Join us in our open culture. Help us build tools. The tools are needed to solve these world's problems. They're needed to make your life better and your creations and your jobs. It's a platform, not just a bunch of tools. It takes more than code. We need the community to help us build that platform together. And then finally, I say openness changes the world. It's something we believe in wholeheartedly at NumFOCUS, and hope that you will help us in that pursuit as well. Thank you very much.
So if you have any questions, please raise your hand and I'll be passing the microphone along.
It is very nice to see an overview of different programs that NumFOCUS is support. For me as a beginner, joining and I only see like 2 or 3 libraries extensively, but didn't see how the entire ecosystem works. How did you get involved as a very beginner, but with some technical background?
So that's a good question. I hear a lot, how do I get involved? And to be honest, it's somewhat challenging to answer all the time because we have so many people involved at this point. If you're a technical background, I think one of the coolest things you can do is just go and start contributing to the code. And now contributing to code doesn't necessarily mean that you have to get a pull request submitted. It could very well be as simple as, next time you use your library, use the release version and see if there's any bugs. And if you find a bug, just go report it. It's very hard for an open community to tell what bugs they put out because they don't have the resources to stress test like you might do in an enterprise environment. If you want to start getting, I think one of the biggest challenges every developer has in these projects is being able to review all the code coming in. And so going and just like looking at some code on GitHub and seeing what other people are submitting in PRs and asking why, or maybe pointing out, hey, you made a spelling mistake here. It's not annoying, it helps because any update to that code helps it for everybody. Then if you do want to get fully involved, there's dev guides on pretty much every one of our codes. If you go, there's a contributing file almost on every single one. They have a GitHub repo. If you go to GitHub NumFOCUS/NumFOCUS, there's a list of all our projects and where to navigate the different mailing lists and things like that. And look at their contributing guide and learn how to contribute to them in a good way. I don't think that it's always necessary that you contribute to all the projects or maybe don't even bite off too much. Go find an easy bug first and try to manage that. Last year we had a documentation sprint for pandas. And documentation is one of those things that's just very challenging for us to manage because there's so many different ways to document something. If you find some documentation kind of hard to read, first, welcome to submit a pull request, but even writing a blog post and saying, hey, here's something I learned by reading this, and then forwarding that to maintainers to help them understand how somebody might have misread something or a better way to write something. In the documentation world as well, we're primarily English-based. We'd like to figure out a system for putting together documentation for the rest of the world. So many different ways, and as always, like the events here, come to your meetup groups. Or encourage others. Bring a friend to the next PyData LA, which I believe is happening next year. I got confirmation. So many different ways, and it doesn't always have to be the code. Remember, there's the whole ecosystem.
Thank you.
So Wikipedia asks for money a lot. Is that a model that you've considered?
Yeah, and we do ask for money a lot. Join our mailing list. That's the first way. Send us money. I will say that if you look at our annual reports, it actually breaks down like where our money comes from, where it goes. A lot of our money comes from these events. Our contributor donation model, where like Wikipedia, they have millions of users a day who visit a website. We don't have millions of users visiting any one of our web properties, so it's not the best strategy to just put my face or Leah's face on those websites. But we do have a donation drive every year. We have sustained membership drives. But the largest portion of our money comes from grants from governments to build these codes for science. Then it comes from corporate or events like this one. Then it comes from corporate donations. So if you are in a place where there's a corporate entity who wants to give back to reduce the risk of these tools failing, please contact Leah. She will help you get a donation from them. And then members kind of comes last. They're last in the amount of money we bring in, but they're, in my mind, maybe first in importance. And so because of that, every person who donates gets to vote on our board and participate in our programs any way that we can. So.
So obviously it would really help if companies gave money, but I'm wondering what other things companies could do that would be really helpful, like maybe if the cloud providers made CI easier or maintainers or whatever. What's the next most important thing after money?
So I think and I've been talking with lots of different cloud providers. So Azure just released their CI/CD system, which looks amazing. And they've even made us our own special account for our projects. I've talked with AWS and other cloud providers to give us some of that CI/CD. The one thing that we can get compute from some of these people, but the hard thing is actually getting the expertise to run those systems. I had a call with many of the heads of these programs a couple of weeks ago, and they said, how do we engage the DevOps community or even the design community? So while we're very good at engaging scientists, we're not so good at design and DevOps and those things. And companies have those people, and if they do find people who'd like to contribute to our ecosystem, we're in desperate need of those folks. So in-kind donations of people's time on those things, and we have different ways that we can recognize that. Then also, like, donate your venue. Probably the biggest expense to any one of these conferences, the single most factor that makes or breaks a PyData or a JuliaCon or a JupyterCon or any of these is a venue cost. And a lot of big companies, they have a room with 50 people. You know, reach out to the community and say, hey, would you like to use our room so you can all meet and talk about the code and teach others and educate. I think we have one that far
back. Thank you for your talk. My question is regarding what investments or vision you have for the interpersonal skills that are key to promoting as well as to perhaps attracting various different types of talent to collaborate with engineers.
Thank you for that question. I should have included project managers on that, product managers on that list of people we have a hard time engaging with. We have a few programs. So first one is our DISC, or Diversity and Inclusion in the Scientific Computing, which is a program led by Gina Helfrich, who isn't here, as a PhD in women's studies from, I believe, Harvard or some one of those Eastern schools. Not the left coast. Yeah. But the
what's her name?
So we have a diversity program. We also have started doing a lot more programs with community managers. So our OpenSci and Jupyter both have community managers and operations managers, and we used to have a call every week to like talk about how to manage these codes. I think it's kind of gone up and down. So if you get in touch, if this is of interest to you, we can like hook you up with the rest of our community who's kind of tackling some of these issues. But in the projects, I've put together one proposal to bring together community managers for multiple pieces of our projects, and the road mapping is another side of that, of like getting together to talk. I always tell people coding is a social endeavor, and we need to learn social skills. I mean, a lot of us go to the internet to code in the early days because we didn't want to talk to people, but hey, what we were doing is just talking to people who don't see their face. And that's fine, there's no problem with that, but bringing in people who understand how to talk to each other and guide communities is very important. And the slide I skipped was from a famous informational scientist who studies community management, and so I was going to talk about it, but we ran out of time. But thank you for your question.
So I have a question. I took off 2 days of work to be at this event Monday and Tuesday, and on Wednesday I have to go back to work and tell my boss and tell my boss's boss and tell their boss what I did. What bullet points could I give them to help move the needle for them about why PyData and NumFOCUS are important?
So I don't know. Thank you for your question, James. I appreciate the prompting. James is a director of the board, so he helps keep me honest sometimes. If you go to the desk, there's a pamphlet. If you have a boss who is interested in helping, there's a corporate sponsorship that talks about how to become a corporate sponsor. There's also how the tutorials, and it talks about the needs we have. There's a whole sheet there with many of the different ways we use the money. And at the end of the day, just kind of going back and showing them, I think the most powerful thing is going back and showing your boss and your team like the different tools and different ideas that you learned. Have a lunch and learn and show off the presentations that people gave. Show them how you can innovate in the community. Some people come here to learn who's available to be hired. Some people come here to just learn new tools and methods. But if you don't tell your boss, you don't tell your colleagues or maybe your lab mates or whoever you might go back to about what we do, then they won't learn and come back with us next year. But if you are in a position that you'd like to get more involved at the corporate level, please talk to Leah, and we have a pamphlet that's more guided towards that sort of literature. And I believe we're all done. Thank you very much for bearing with me.